Dr. Muneendra, we may start now.
Good afternoon, everybody, and welcome back to the second session of this faculty development program. In this
Upendra,
session,
1 minute. Upendra,
yes, sir.
you just check it. Muneendra is here or not? Dr. Muneendra, just I will
Yes,
check.
sir. Yes, sir. We can start, sir.
Okay. Yes, Muneendra. Go ahead. It's Upendra, go ahead.
Okay. So, welcome back, everybody. In this second session, we are going to have a hands-on session by Dr. Muneendra Ojha. Dr. Muneendra Ojha is currently serving as an assistant professor in the Department of Computer Science and Engineering at IIIT Naya Raipur. He completed his PhD from IIIT Allahabad and his MS has been completed from University of Missouri, Columbia, USA. His current research interests include multi-objective optimization, evolutionary algorithms, machine learning, AI, and multi-agent systems. Today, in his talk, he will be conducting a hands-on session on Google Colab, that is an online platform for building machine learning models. So with this introduction, I now request Dr. Muneendra Ojha sir to deliver his talk. Over to you, sir.
Okay, thanks, Open, for the introduction. Today's talk, as you all know, is on the topic of how we work in Google Colab and what we can do if we don't have high efficiency systems, how we can run our program. And in fact, this is a very nice platform which I will demonstrate to you today. And if you do not know about it, you will get a good hands-on with this session. I hope it will be beneficial to you all. So let me share the screen. In the meantime, I would like to thank Dr. KP Singh and IIIT Allahabad for giving me this opportunity to present unto you the for me to deliver this talk and present unto you the efficiencies of this platform that I'm going to demonstrate in front of you. So Google Colab is actually stands for Go Laboratory. So this is a platform which is provided to us by Google and it is free of cost. So as you can see over here in my screen, if it is visible to you, I hope my screen is visible to all of you. Sir?
Yes, visible to me. Yes, yes.
Okay, great. So I'll continue. So this screen has we can start a collab by
Just 1 minute, Dr. Muneendra, 1 minute.
Yes,
also, I would like to request all the participants, if you have any query, you may write on the chat box or you can unmute and ask. Or I will request Dr. Muneendra, after 10 to 15 minutes, you may take the questions if you wish.
Sure.
From the part. Okay, that's all.
You can ask question as and when you feel like, because most of the time you forget about our questions. So it is free. You feel free to ask questions whenever you feel comfortable and you have a query. So I'll start by starting a new session of Colab, and you can see Google Colab can be started by this URL. You have colab.research.google.com. Okay, so if I go over here, it will ask me with which account I want to open my Colab file. So at the present moment, I'm logged in with my personal email ID, muneendra.ojha@gmail.com. For you also, it will be if you have multiple logins, it will ask you with which ID you want to log in. So let's assume that I want to continue with the current session. So I open a new Colab file, new notebook. I don't know how many of you are familiar with Jupyter Notebook or not, but Jupyter Notebook is a kind of notebook in which you can have Python code, Ruby code, and a lot of different codes. You can run them in the cells, which are called code cells. And in these cells, you can write your code. Like if I want to write just a simple Python instruction to print this word hello, then I can run it and I can get the output in the output. Jupyter Notebook is this Google Colab is actually borrowed from Jupyter Notebook, and almost all the functionalities of Jupyter Notebook are present in this Colab file. So on this interface, if you would observe, there are a lot of menu options. So you can change the name of the file. So let me just put a test one, indicating that this is the first one in which I'm going to test something. You observe over here. Let me zoom it a bit, so probably it will be clear to you all. I think this zoom level is comfortable to everyone. So you see there is a connect button. With this, you can just click the nearby arrow button, and it will tell you connect to hosted runtime, connect to local runtime. You can manage sessions and focus the last run cell. So if you focus on these two options, connect to hosted runtime and connect to local runtime, it actually tells you that hosted runtime is the Google backend on which you can run your program. When you run this program, all these codes will be executed on the Google backend, Google server. You can also connect to a local runtime. So this will act as a local machine Jupyter Notebook or Google machine, local machine Colab file. So if you assume that you have sufficient computing resource, you can connect to local runtime as well, and with that it will execute the program onto a local machine. However, let us start with the hosted runtime that is on Google. So as soon as I press this connect to hosted runtime, it will start connecting, and you see it after initializing it says connected, and it gives me something else. Now it is telling me how much RAM and how much disk I am utilizing on the Google. See, it says there is a question that says that can I share a notebook with exercise? Bharatji, at the present moment, I have files that I'll share with you, but I am hoping that whatever instruction I'm giving you, you will follow it. So till this point, I have just opened a tab. I have not actually written any code. So I think you can follow and you can continue with me. Okay, whatever I'm doing, you can do it. I will although share the file. So you see, I have this RAM and disk space that I'm utilizing on the Google backend. Okay, it says Python 3 Google Compute Engine backend, and I'm utilizing 0.77 GB of RAM and 32 GB of the disk. Although this whole disk is not devoted to this runtime, however, I'm utilizing 32 GB of the 1 terabyte that is provided to me, 107 GB that is provided to me. So you see, I have this new file and I have this statement. If now I run it, to run, you should press either Control Enter or Shift Enter. So highlight this cell and press Shift Enter. So if I press Shift Enter, it will create a new code cell just below this code and execute the current one. However, suppose I delete it, and instead of pressing Shift Enter, if I press Control Enter, it will just execute the current cell and give me the output immediately beneath the code cell. Okay, it's a very small mild difference. However, this will depending upon your comfort. So I normally do Shift Enter. With Shift Enter will create a new cell. So this is just how you create a new Colab file and you can start working. However, for the task of for the purpose of this lecture, I have prepared few Colab files and that I have shared with you. So I'm going to copy this link in the chat box. If you can, probably please access this and let me know if you are able to access the drive folder that I have shared with you. You all should see something like this in which I have 4 folders, class 1, 2, 3, 4, and I have a IIITA.ipynb file. I have made it open for all, but if you are not able to access it, just let me know. I'm waiting for your response. Are you able to open this folder?
You may respond on the chat box if you are able to open. Anyone?
Accessible. Okay, so Mr. Vinod says that it is accessible. So please open this first file, IIITA.ipynb. Okay, how would you open it? You can open a collab file just like I did. Okay, like this, collab.research.google.com, and from here you can go to file, locate in drive, and locate in drive. Then you can go to this folder which is shared with you. So you can go to shared with me, but for me it is not shared, so I will just immediately go to the folder that is there, and I will open this IPynb file. Okay, so I will explain again. You go to file, you go to open notebook. Okay, open notebook. If you click on open notebook, it will ask you where from you want to open, and you can go to Google Drive. From Google Drive you can either type the name, or you can download and upload as well. Okay, both ways you can open this file. Okay, there is another method with which you can open this. You can directly double click on this file. For this you need to have some connected apps. Okay, so in my Chrome I have Google Collaboratory as an connected extension. I have this app extension Google Collaboratory, which is connected over here. So it will ask me with which app you want to open this file. When I click over here, you see I can go to my drive. So I press locate in drive. I go to my drive. My drive, I have this folder IIITA, and in this folder I can see this file. When I double click this, I will ask me with which app I want to open this file. So there are connected apps. So I say that I want to open it with Google Collaboratory, and it will, when I select Google Collaboratory, it will open the specified file for me. Okay. Now this is the file that I want you all to open, please. If you open, please let me know. I can move on. So I hope everybody is, yes, Virenji is saying that he is able to open this file. So now I will move on. And everything that I wanted to share is in this folder. So class 1 folder, class 2, class 3, class 4, all these collab files I will access and I will work through them. So it is better if you have this file, and the data is also stored over there. So I have shared everything for the purpose of this tutorial. So let us start. So for the time being, I'm closing the chat panel so that you'll see the whole screen. Now on this, as I'm going to discuss the content of this collab file, so I'm hiding few of the things, like this menu I'm hiding by clicking over here. So it says toggle. So I have hidden the menu. Now I'm making my Chrome full screen. Now, okay, so this content should be visible to you. Okay, so in collaboratory, actually, because of since this is a faculty development program, most of you are faculty somewhere in some college, and you need online tutorials. So I have found that with Google Collaboratory, I was able to prepare my lecture in a beautiful manner, and with this, I am actually able to present whatever I am willing to say. I can put images, I can put diagrams, I can put link to the resource that I want my students to see, and at the same time I can put mathematical equations, I can put HTML markups, I can highlight, I can format my text, and the best thing is I can run the code over here in this. So there are two types of cells in Google Colab, as just like Jupyter Notebook. The one is called markdown cell, that is text cell, and the other is called code cell. So you see it shows over here, one is a code cell and the other is a text cell. Text cell is also called markdown cell. Okay, so there is nothing markup, it's all called markdown cell. If you click over here, you will be able to see the table of content you can see table of content over here. If you want to search something, find and replace, you can click over here. You can do find and replace. You can see the code snippet with this button, and you can see the folder associated with this Colab file at the moment over here. So there are 4 menu options which are always visible to you. So at the moment, I am actually willing to show you how to format the text. So just double click this. Okay, when you double click the markdown cell, it will show you the content that is actually written, the code that is written. So in markdown also, just like LaTeX, you write so many things, but what is visible to the printable version is something different. So over here also, it follows having the LaTeX structure. So I have written over here, formatting text in Collaboratory, a guide to Collaboratory Markdown. So you see this text is visible to you. This text is visible to you. Okay. And this is the title text that is given over here. So if I delete this, this is the first title. This is the title. Okay. Formatting text in Collaboratory, a guide to Collaboratory Markdown. So after this, you have 3 equal signs that indicates that this is the title of the whole Colab file, and it is displayed just like this, the biggest bold format, which is shown over here in the table of content. So you have 3 equal signs indicating above these 3 equal signs, you have the title, and I have provided this link with which you can access the shared folder that I have shared with you, where I have kept all the Colab and data. If you press Shift Enter, this cell will be shown, I mean kind of executed, and will be shown to you how you can print it in the printable format. So now you see no inner code is displayed, it's only showing what is needed to be needed for the end user. Okay, now if all these are cells, so this is one cell, this is other cell, this cell has got something like this. So these hash marks indicate what is the level of title. Okay, so if I put this single hash, it means it is level 1 heading. If I put 2 hashes, it shows that it is level 2 heading, 3 hashes, level 3 heading, and so on, just like the HTML, H1, H2, H3, and so on. So there are 6 levels of headings that is provided in it. After that, I have put 3 minus signs like this. You can put as many as you want, but 3 is sufficient. With 3 minus signs, we can have a line displayed like this. Okay, then you can put all these content, whatever content you want to put. Links can also be provided like this. So you see, if I have to present a link, and over here you see this is the way it will be displayed, and this is how it is written. So on the left hand side, what is actually written, and the right hand side, what is actually displayed. So you see the content that I want to be a hyperlink, like over here it says the original is the hyperlink. So the original is surrounded in square brackets, and after that we have parentheses. Immediately following that we have parentheses, and within parentheses provide the link to which this hyperlink should actually target to. Then you have different types of headings. So this is heading 1, this is heading 2, quick reference, and so on. So these are different type of formatting. So you see over here I have different types of formatting. So it says headers are created using hashes. Use multiple hash for less emphasis. For example, single hash, this is h1 tag, and you have got 5 hashes, this is equivalent to h5 tag. If you want to make something bold, surround that using double asterisks. Okay, it will make it bold, surrounded with 2 asterisks, and it will make it bold. If you surround the content with single asterisks, it will make it italics. Okay, to make text is italic, use a single asterisk. If you want to do underscore, this will also make it italic. So either you use underscore before and after the content, or you use single asterisk. Both of these things will give you an italic formatting. Then you have, if you want to strike through, use 2 tildes. Okay, just like this over here. So you want to use a strike through, use two tilde. Okay, while if you want monospace text like this, normally what we do when we have to specify some code in the markdown, we write in monospace and we use the backticks. So backtick, just beneath the escape button you will find this backtick, okay, on your keyboard. Now if you want to indent something, like, let me just show you over here. Yeah, this is indented code, right? So this is equivalent to alt h1 tag. So this text is indented. You see, it is shifted a bit of spaces ahead. So with greater than sign, you can do it. So if I remove this greater than sign, you see that this will shift backwards. Okay, and if I put the greater sign back, it will shift over here. So this is shifting. So you can indent it. Similarly, if you want something to be numbered, what you can see, what you can do, I can put it like this, one dot, and it will immediately become numbered. If I want more, let's say I want to make it 2, but there should not be spaces, I will put it like this and it will be 1, numbered 1, numbered 2, and then I can put number 3. Sorry, over here I can make it number 3. It will be like this. Fine. And depending upon how much space you want to put, you can use spaces, or you don't want to use spaces, that's up to you, but it will automatically adjust all the spaces, right, for all the levels. Similarly, if you want something to be within so this is numbered ordered list as per the HTML. If you want unordered list, you can put a star. Okay, so you see this is unordered, bulleted. These are numbered, these are bullets. So you can just keep on putting stars and it will create number, create a bulleted text for you. You keep on creating bulleted text for you. Now this is important. An exclamation mark, an exclamation mark character in front of a link turns it into an inline image link. Okay, like this. So you can put an exclamation mark and then text and link to an image.png, just like I have. I think I have done something for you. Yeah, this is the one. So you see, I have put an exclamation mark and then within a square bracket I have put the name of the image. So what I can do, I can change this name, bench in the park. Okay, bench in the park. You can put any text over here, and in this will, and after that, after square bracket is closed, after that you will put within parentheses the link to that file. So at this point I just searched it for you. So this bench in the park, this text is written for your own understanding that which picture was here. So suppose in case you lose this link, even then you could understand with this description that what was the picture that I had embedded over here, and then you can research that image and put over here. So you see, this is the image that will be displayed. Apart from this, if you don't have the exact file to display, what you can do, you can, like over here, you can do a screenshot, screen capture, and I hope you all know this shortcut that when you press Windows Shift and Windows Shift S button, it will ask you to take a snippet. Okay, so let's say I'm taking this snippet. So again, I'm telling you this shortcut, Windows Shift and S button will ask you to take a snippet. So this snippet is what I want. So suppose there are many times when you think that you want to put something, you have a book, and from book you want to take a screenshot, capture an image and just paste it over here. Okay, so this is how you can capture the text and paste it over here. So, or probably I can take an example and show you. Suppose I take any one file. Let's say I open, let me open any file. So this is the file, and I want to biological matchings. Okay, so this is the image that I want to copy. Okay, so I can just click this image, I can copy this image, and I want to paste it over here. So let me just create a new cell above it or below it. So I am creating a new text cell. Within a text cell, what I can do, I had copied over there, I can press Ctrl V and it will write something. Don't worry about what it is writing, just paste it and press Shift Enter. So it actually didn't copy this. Okay, this is a copy error. This is not an error of our mechanism, it's the error of the file because it is created in LaTeX, so it is not allowing me to copy that. So let me take a snapshot. So I am again snipping it. This snipping tool I was telling you, I snipped this image, I took this image, copied this image, and over here in this cell, this is a markdown cell. I'm pasting over here. And when I press enter, see, this is the image that has been copied from there. This was copied, and I can paste it over here. Don't worry about the content, because if you press the double click the content, it will create something like this. So remember, I had told you that put an exclamation mark and after that a square bracket, and you can, and within parentheses you put the link. Now here there is no link because I had just copied from there, okay, and pasted over here. So there is no link. However, a lot of content will be written, a huge amount of content is written just to represent this small image. This small image is represented like this. You can put it. So this is how you can put images. Then ordered list, I told you. Unordered also, I told you. You can use links, like these are the links you can put, right? So these are the links. Now about mathematical equation, you see there are a lot of ways you can put mathematical equation in the Colab file. So you see all of these are equation. First of all, as per LaTeX, you start dollar and end with dollar. These are the delimiters, and if you want to write an equation in line, then you can use it like this. So let me just write it. This is an inline equation. Fine. So this is an inline equation in which you put dollar and delimiters, and within these two delimiters you can put your equation. However, what you can do, you can also put double dollar, and within double dollar you can write anything like y square equal to, right? So something like this randomly. So within double dollars you can write it, and it will be centered. There will nothing be written. If you don't want anything to be written in the equation, in a text written in this equation, you can write it like this. You see all of them are, you see over here, all of them are single dollar delimiter, and all of them are starting from left hand side. However, this equation that I have written over here, this one, the effect of this one is actually at the middle of the content. So if I just press shift enter, you will see that this equation is at the middle. However, these are inline. These are all inlines. And if you know how to write equation in LaTeX, probably your life will be very easy and you can perform everything over here. So these are the things which I don't think you will be, I need to tell you how to write equations in Colab. And again, you can write these, you can create tables also. So you see these tables, this is the table. So this is how you write tables. So you write first column name, and then the vertical or our logical or symbol, and then second column title. So this is the effect. This is the code that you write, and this is the effect that is being displayed over here. So first column name, and then or symbol, and then second column name. So these two will look like this. Then in the second line, you write three lines. Three lines indicating, you remember that I had showed you that if you want to draw a longer line, you have to put three dashes. So 3 dashes and then a vertical or and then 3 dashes. So every time you write a content, you will have to put this over here because this indicates that there are two columns. So every row must have two columns. So first column, second column, first row, second row means these are the line. This is the line. Then first column, second column, first column, second column, right? So row one, row two, just like this. So the code you write becomes something like this. Horizontal rule done with 3 dashes. So when you put 3 dashes, this horizontal rule will be displayed. Colab uses mark.js JavaScript and so is similar but not quite identical to the markdown used by Jupyter and GitHub. So this is a bit different. It's JavaScript is a bit different. It's identical but not that what is used by Jupyter and GitHub. In GitHub you would see some MD files which are markdown files, but they are different. This is different. The biggest differences are that Collaboratory supports Latin equation like Jupyter, but does not allow HTML tag in the markdown unlike most other markdowns. However, things have changed. Okay, this thing is not true, no longer true. The okay, when I say that this is not true, I'm not 100% correct because some of the HTML tags work, some of them don't work because the style sheets don't work. So any styling you want to implement, that doesn't work. So you see these things, like this is the exact thing that I wanted to show you over here. I have the font tag that works over here. So I have specified font color equal to brown and then surrounded it with the font tags. And this content is brown, colored as brown. There is nothing, though, no way you could color your text in normal Colab markdown functionalities. So Colab doesn't provide you anything like that. However, you can use HTML tags to color your code, color your content. So this is the text. So this is my text. Let me remove the text. So these are the HTML tags within which I have put my content. So this within this, what I put, first of all, I write. Let me just write the content. Okay, building machine learning foundation. So I have written this content, building machine learning foundation, and you see why it is such big, because I have put hash, single hash over here. So single hash means the big title header one. And now if I surround it with double asterisks, I will, what I will get? I will get bulleted, head, bold letter. Okay, I will get letter. So this is how I can change the colors as whatever I want. I can put navy, I can put red. Now I can, as I can put use HTML, I can also use some kind of referencing also, like anchor tags. You can use anchor tags over here to create href. Okay. So this is so you can use anchor tags over here to create the referencing. So you see I have put this reference over here, and if you see the code, I have written a href equal to hash ref1. So hash ref1 is the name of the anchor to which this link should refer to, and I have put simply a text 1 indicating IIIT referencing pattern. So this pattern is not actually provided by Colab. However, if you want a professional presentation, you can create your own, and this actually puts a huge emphasis on the way you write your code. So this referencing example, I click over here and I will go to another section of this same Colab file. So you see I click over here and I go to references, and now one-stop shop. So you will see the content written over here. So this is called ref1. Remember I had named it hash ref1. I had called it hash ref1, right? So hash ref1 is something, and that is the name of the reference that I want to refer to. So if I click over here, I will go to hash ref1. So hash indicates that is the name. Ideally the name is ref1. So name equal to ref1, and this is how I represent my references. So I can put on everything over here, and you see all of these codes have been written. Okay, all of these codes have been written in LaTeX. You can use either equation, you can use align, you can use double dollar, anything you want you can use depending on how much LaTeX you know. You can create complex equations, and then you can number them as well. Like over here using the tag, I have this tag with which I can number the file. I think that is enough for the Colab, and as we move on, we will also see how to work with Colab files now. So that is something that I will now shift from, and I would request all of you to open this class 1 file in this folder, class 1, and you have this dl class1.ipynb. ipynb in fact stands for interactive python notebook. Okay, ipynb. So I would request all of you to open this dl class1 ipynb, in which I tell you how you can use Colab file to use the data imported and then run your library, import your libraries, and create the machine learning models. Okay. Okay, I hope you all have opened this file now. You see, I have this Colab file, and I think you all must have seen this file, opened this file by now. This file contains so many things, and although I have created a okay, somebody is asking for a link to this file. I have shared this link in the chat box. If you refer to this, I can copy paste it again. Okay, so this is the link with which I can you can access the files shared on this folder, and this file is the starting one with which I'm going to tell you how to run a machine learning model. Now you see all the content is displayed over here. All the content is actually present in this folder. So you have my Indian Diabetes Database CSV file, and I'm going to utilize that to create our first model, run it, and see how it is going. So let's start. First things first, you need to connect it. Otherwise, if you don't connect, probably you will not be able to see what is happening. But anyhow, if you press Shift Enter, it will automatically start connecting to your Google backend. Now you see a lot of things are written over here, which actually refers to what kind of data I'm using. But let us start with this part. We are going to load libraries and seed a random number generator. We have initialized our random number. Let me zoom it a bit. So we have initialized our random number generator to ensure that our results are reproducible and loaded our data. So every time we produce our result, it will be producing the same result. Again, if we seed the if you fix the seed random number seed. So from Keras, I'm going to use Keras library for creating this neural network. It is not very tough. There are some of these steps. Main objective at this point of, since this is your first day, main objective is for you to understand how Colab works, how code works, and how machine learning models can be created. Okay, what goes beneath the deep learning model, that can always be discussed in the later sessions. So if I run it at the Google Colab, first in your case it should connect, and then it should, let me restart the runtime. Okay, so if I do a factory reset runtime, it will, yeah. So it has refreshed it. Let me reconnect. Now it has initialized. Now it is connected. Okay, so if I run it using shift enter or control enter, that is up to you. All the required libraries and packages have been imported and the seed has been initialized. Now I need to load data from my Google Drive. So for that I need to mount it. Yeah, of course you can run. You just copy it to your okay, you see, since it is shared, so all of you are accessing the same file. Please don't make any change. Okay, it's better you copy it to your own copy and create your own copy in your file. You can download it from here. You can download it, right? You can download and create your own copy. So this way you will make any change to your own copy, not to everyone. You will not disturb everyone, right? So I have now, okay, so if I want to load data from Google Drive, first I'll need to mount it. So to mount, this is the code which you, and this is something which you really don't need to remember. If you go to this folder, what happens, this is the link which says that mount drive. Okay, so there are three symbols you can see. So this symbol, if you press this symbol, it will automatically insert a cell having this code. So if I just delete this code and I press this, you see this cell is automatically created which has the code to mount the Google Drive. So let me run this code. If I run this code, what happens? It will ask me to go to this link and find out the authorization code. Okay, so I will click on this link. A new page will open which will ask me to choose the email ID. So I'm using my personal email ID. I'll go over here and it will ask to access the Google account and it will ask for authorization. You just have to allow, don't worry about anything. And this is the authorization code. I click over here to copy the authorization code and come back to this file, come back to this Colab file and paste the authorization code over here. Once you paste it, just press enter and it will mount your required Google Drive. Now Google Drive is mounted. Okay, so I'm hoping that everyone has copied the file from here to their respective Google Drive. Please don't delete it, otherwise I'll have to copy again. Okay, so so this drive is mounted. Now if it is mounted, you can go to this you can click on this icon and you see this drive. So this drive has my drive link. Now it shows all the content of your drive. Your drive is mounted. Okay, for me it is my folders that has been displayed over here. For you it will be your content. So this drive is mounted. Now I want to load the dataset. So you see this is the code, dataset equal to numpy.load text using numpy load text library. I hope you all know. I specify the path of the file that I want to load data and delimiter over here, since it is a CSV, delimiter is comma. So I load this file and after that this will be split into two parts. First part is the X, the input, that is 8 columns of first 7 columns represent the input, and last column, the 8th column, actually represents the label. Okay, so 0 to 8 means 7 first 8 columns, 9 columns represents first 8 columns of the 9 column represent your X input, and the 8th column represents the Y. So it automatically divides it into X and Y using this list comprehension. So if I run it, it should actually load everything over here. If you don't know this path, then what do? Let me delete the path. Now at this point I will go to my drive. I will locate that file. So in this case, this is the file class 1. Class 1 has got this Be My Indians diabetes dataset. Now I click over here and see this is the copy path link, right? I can click on the copy path and now I paste over here. So I paste it like double quotation and then paste the file and then run this so that my file will be loaded. I have loaded the file. Now you have defined the model depending upon whether you know deep learning or not. This could be useful to you, but I'm not getting into detail of that. The basic idea is it's a very basic neural network having two hidden layers and one output layer. Okay. So first hidden layer defines that this is the hidden layer with 20 neurons. Input dimension is 8 because I have 8 features. You see, I have got 8 features in the data set. So input dimension is 8. Activation function is ReLU. Then second hidden layer has got 10 neurons. Activation function again ReLU. And third is the output layer, which has got only one neuron, indicating two kinds of classes. Diabetes or no diabetes. Okay, prediction for diabetes, onset of diabetes, yes or no. And this has got an activation function also. So we'll discuss about these, what do we really mean by this activation function and neurons later. But this is the model that has been created. Okay, so once you define this model, you can see the model plot using this model dot summary, and you see these are the comments. Okay, so create model, if you have in the code section, if you start anything with hash, that becomes a comment. Okay, just like Python. So this is a comment, so I'm totally following the Python syntax over here. So I have commented this plot model statement and I'm just running the model summary. So if I run it, it will create a model which is called type sequential. It has a layer and type, so output shape and parameter, number of parameter. The layer is a dense layer, type is dense. None means as many inputs as you want, it can have as many inputs. And then it has got 20 neurons, so 20 neurons over here, and 180 parameter, 180 parameter. Okay, the number of parameter it wants to learn. Then the second dense layer and the third dense layer, that is the output layer. So it has got 10 neurons, 10 neurons. Third one has 1 neuron present in the output layer, and it has got some parameter. So total trainable parameters are 401, and this is the summary of the model. If you want to see how the model actually looks like, then let me just comment remaining and then run this part only. The model has already been created, that is why I commented that. I don't want to create models so many times, so I commented that, and I am printing a DL class1.png file. So this is how a PNG file of your neural network will be created. So first is the input layer. There are 8 inputs. So the first hidden layer, you have got 8 input and 20 outputs. Second hidden layer, 20 input and 10 outputs. Third hidden layer, that is the output layer, that is also dense layer, 10 inputs and 1 output. This is how the model will be created. After that, we need to compile our model. During compilation, we specify what is the loss function, what is the optimizer with which the neural network will train, and what is the measurement of metric with which I want to check whether model is behaving perfectly or not, or how good the model is behaving. So for that, we use the metrics of accuracy. So these are the 3 things we specify at the time of compilation. If I run this, see, it will compile and it will specify these parameters. We specify these parameters indicating the loss, the optimizer, and the metric. After that, this is the time to train our model. Okay, so once I have specified all the hyperparameters for the model, it is time for me to train my model. Model training happens with model.fit function. So fit function will take input x, output target y, number of epochs, that is number of times this whole batch will be trained again and again. Batch size is 10, means number of samples in one batch is 10, and verbose equal to 1. Verbose means if verbose equal to 1, it means all these descriptions will be displayed to you at every epoch. Okay, so these are the parameters of the function. It's very simple. There can be more parameter, but I will discuss that later. So let me run this and fit our model. So when I say epoch means suppose I have 1,000 samples. So 1,000 samples will be shown to the model one time. That is one epoch. If 1,000 samples are shown to the or trained to the model 10 times, that makes it 10 epochs. Okay, batch size is 10 means out of 1,000 samples, I'm first showing 10 samples to my model, then calculating the error of those 10 samples. That error is propagated backwards, so network is trained on those 10 errors, and then I move on to next 10. Okay, so suppose I have 100 samples. So what I'm doing, I'm first feeding 10 samples, then calculating the error, and then updating the network. Then again passing the 10 sample, next 10, then next 10, then next 10. I do it 10 times. So 10 samples, 10 iteration makes it 100. That makes one epoch. Okay, so I hope you understand the difference between epoch and batch. So if I run it for, let's say, instead of 150, I run it for 15 epoch and I press shift enter. See, these are the epochs which are running. So first 1 of 15, 2 of 15, 3 of 15 and 77 batches are running. Every batch is of size 10. So you see how many samples did I have. If I just print over here, let me print the dataset shape. Unfortunately with this is a big problem. If I press, there are a lot of shortcuts in Colab which start with Control M, and when I press Control M in WebEx, it mutes me. Okay, so I'm not pressing the shortcut. I will just print the dataset.shape, and if I run it, it will tell me, yeah, 768. Basically 768 samples are there. Okay, so if I have 768 samples and I divide one batch, if I make one batch of 10 samples, it means I will need 77 batches for training all the samples that I have. Of course, last batch will not have 10, will have only 8 samples. So 77 batches are formed, and every epoch contains 77 batches. Okay, so how many epochs do I have? I have 15 epochs, and at the end I find accuracy is 65%, loss is 71%, and so on. Okay, now I need to evaluate my model. Ideally, what should have happened, that I should have divided my dataset into two parts: training dataset and testing dataset. And out of training, I should have taken one validation as well. So here you can specify validation. If you want, you can, let's say I again train this model using the validation split. So let's see what happens if I do a validation split of 0.33. So it gives me validation loss and validation accuracy as well. So loss accuracy of the training, then validation loss and validation accuracy is also given to you. So 0.33 means 33% of the total number of samples are kept for validation, and out of remaining 77% is utilized for training. So you get the validation loss, validation accuracy, right? You can evaluate the model. You can evaluate the model using the same samples. It gives you 72% accuracy, not a very good accuracy, but it's still just, this is just for the purpose of, for the sake of demonstration. So I'm doing, otherwise this model doesn't look that efficient. We can save our trained model using this model.save. It will save it in the tail underscore class one dot model, and it will save it. If you have to make prediction, you can utilize the same model, and let's say it uses this same sample on which it trained to take the to predict it. Okay, so for prediction, actually we can use predict class or just predict to see what is happening. So both of these will work. If I run it and then summarize, you see, I just want to see what is the actual. So in it, since it is how much accuracy, I have got 72% accuracy. means 3/4 of samples are correct. So the first sample was supposed to be 0, means no onset of diabetes. How it's giving me 0, however expected was 1, means onset of diabetes was there, however it is giving me 0. In second case, my expectation is same as what is being produced. Third case also as expected. Fourth case also as expected. And fortunately, fifth case also as expected. Only first one over here is giving a wrong classification, wrong prediction. Anyhow, with 72% accuracy, 72% accuracy, this is the one. I think most of you are more interested with attendance than what is being discussed over here, right? This is your first day, don't worry about attendances. Okay. So this is the way we created our first model. Now let's move on to class 2, and you see, yeah, please open class 2, and you see in this we do data splitting for verification. So in this you see, we will now evaluate the performance of the models that we have created. And model you can create in either the regression model, logistic regression model, linear regression model. You can create decision trees, any type of model you can create. However, in the idea is you should divide your data set into two parts. The one part should be for training. So suppose you have 1,000 samples. So ideal scenario is that you keep 20% of those samples which you have for pure testing, and remaining 80% for training. Okay, so if I could annotate, you see, if you have 100 samples, out of these you keep a divide of 80/20, right? This you preserve for testing. Now from this 80 you divide it into a further 80/20, okay, and this 820 is validation. This is for validation, and this is utilized for training. This is utilized for training. So this is our complete data set. So if you have 100 samples, out of 100 samples, first you divide those 100 samples into 80/20, means 80% for training and 20% for testing. The 80% that you have kept for training will have further division of 80/20, in which this 80% will be used for actual training, and this 20% will be used for validation. For those people, I have seen this confusion in many people who do not understand the difference between validation and testing. See, validation is something like when I teach something in my class, I ask a lot of questions. Okay, so when I ask these questions, what I'm doing, this is my teaching time. Okay, like right now, I'm teaching, I'm telling something to you guys. This is my training time. I'm training you. Okay, and during training, if I train you on something, if I tell you something that, okay, Mr. X and so on, so this is how I mount the Google Drive. Okay, I told you, so I trained you, and then after some time I asked from Mr. Y that, okay, Mr. Y, tell me how do I mount the drive. So when I'm training, at that time, if I do a quick testing, that is called validation. Because if you are not able to perform, or if you perform or don't perform, depending on your response, I will get to understand how good I'm teaching. If I'm not teaching properly, I will change my method. So this testing, which is called validation, is for the sake of tuning the training in right direction. Fine. So the questions that are asked in a class are validation kind of validation testing. Okay, with that, the teacher tries to understand whether students are learning properly or not, the method in which the students are being taught is good or not, or does he or she need to make some modification to the training mechanism. So this validation actually helps us understand whether my training is going in the right direction or not. And this 80-20 keeps on changing. First of all, some samples will be part of 80, then some other samples will be part of 80, then some other samples will be part of 80, then some other samples will be part of 80, and so on. And the remaining will become 20. So it's not like this 20 will always be in validation. It may happen that sometimes you train on these 20 as well and put some other 20 for validation. Now, when training has completed and all of these things have finished, so this training has completed, this 80, all of this gone, fine. All these have happened. So validation happened, training happened, and you have trained on everything that you have taken, fine. So this training is complete. Now I don't need to train. So this 80% is done. Now, when you are satisfied that okay, my students are properly trained and I think they can face the heat of examination, so semester is over, now is the time to face the final examination, then you say that your model is ready. Okay, and then at that point you take your 20%, and on this 20% you check the goodness or fitness of your students, then that is called the actual accuracy of the model. So this 20% is never used in the time of training. This is always used when you have to specify the efficiency of your model, actually report the efficiency of your model, then you utilize this 20%. Okay, so again over here I connect and then I mount it. Do the same thing. Paste this authorization code over here, press enter. It will mount the Google Drive on this Colab file. Okay, the drive is mounted. Now I'll run this. You see all these things are exactly same. It will produce some error. I'll tell you why it will produce error. It has produced this error because this path is not correct. I have changed it, so I need to correct the path. So I'll go to my drive. I'll browse to the folder where I want to take. I have this file, the P9 dataset. I will copy path and I paste it over here. So this should be the correct path. I paste the correct path over here, then I run it. All of these were there. Okay, you see this model evaluate XY and everything is happening, validation accuracy. So I have split it on the basis of 3377, 3367, and it is running. So 67% and 33% for validation, 67% for training. So after that, it gives me 75.39% accuracy. Keras allows you to manually specify the dataset used for validation training during training. So in this example, we use the handy train test split function from the Python scikit-learn. So you can this is what we are doing is we are using the scikit-learn library over here. Okay. So a scikit-learn machine learning library to separate our data into a training and test data set. Use 67% for training and remaining 33% for data for validation. Now the validation data can be specified to fit function in Keras by the validation data argument. It takes a tuple of the input and output data set. So you see. So over here, what you are doing, you are again loading this. So let me just copy this so that it doesn't produce error. Okay, so I have this content which I have shared with you. I will utilize this p-minded dataset, and I have created this neural network model. I compiled it and I fit it. While fitting, you see the validation data is specified as X test and Y test. Where is X test, Y test? We are using the train test split function of scikit-learn. We see train test split. I think it should be train underscore test underscore split function. So I want to make it monospace, so I write it like this. Now it looks better. Train test split function from the Python scikit machine learning library. So using that, I have split into 67% for training and 33% for testing. So now I have X train, X test, Y train, Y test. When I say, okay, I think this question is for me. Can share this program? No, Krishna. I think I have shared the program, right? You can, if you are late in the session, you can ask some other participants to give you the link. I have shared it for you all in this folder, and this is DL class 2. This is DL class 2 which I'm referring to. Okay. Right. So xtrain xtest, xtrain xtest, when I say xtrain xtest, this xtest is not the testing data. Remember, if you have to have testing data, you have to keep it separate. We don't train on test data. This is validation data. Okay. So validation data, X test, Y test. There happens training on validation data as well. So validation data is not the test data, because on validation data, sometime or other, you train your model. So your model has seen this data. So that will not be called the testing data. So now we have divided into X train, Y train, and validation data equal to X test, Y test. Number of epochs 15, batch size equal to 10, just like the previous code. When I run it, these are the epochs. Okay. Now you see, at this point of time, there are not 77 epochs, 77 batches which are running. Although the batch size is still 10, but it's only running 52, because 67% of the data is the one on which we are training. We are only training on 67%, and 33% is for validation. So it is only creating 52 batches. 52 batches. And finally, our accuracy is 66%, which is not very good, right? So in spite of this, you can have manual key-fold cross-validation. So manual key-fold cross-validation can happen in this way, that you perform stratified key-fold. So this stratified key-fold you see from scikit-learn library. You can import a stratified key-fold function. The job of a stratified key-fold is that it splits the dataset into a specified number of folds. So you specify how many number of folds, number of splits, 5. So it will perform
Even 1 minute, Muneendra, if the audience have the questions in between, they may ask also. Otherwise, he is continuing. If anyone
yes,
have any question, please, then you may ask.
Yeah, sure, because I would definitely encourage you to ask questions. Only then I'll be able to. So this is a kind of validation for me as well. You validate
Yes, you
me
may
whether I'm in the
unmute
right
yourself
direction
and
or
you
not.
can ask if anybody have a questions.
Yes, sir.
Because that will be better for the experts also to discuss the nitty-gritty, how to handle the data and how to use, rather than monotonically, because this is the one issue with the online. But we will be happy to get your questions, so that accordingly it will be designed and planned.
Exactly.
If anyone have any question, please.
Yeah, sir,
Before moving, Dr.
question
Muneendra will move to the next
on the
discussion.
k-fold, the
Yeah, yeah.
stratified k-fold.
Yeah.
What exactly? How is it works and why is it needed for the
Okay,
data.
that's what actually I was going to explain. See, over here, stratified key fold means, first of all, you understand what is key fold cross validation or not?
No.
Okay, so cross validation means if suppose you have a training data set and training data set is like this. So just pardon my drawing. So suppose I have my training data set, I divided it into several parts. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 parts. So just imagine that out of I have 100% of data and I have divided it into 11 parts, and these numbers are just a hypothetical number. You can divide it in as many parts as you want. So for the sake of training, what happens is that out of 11 parts, I will take, let's imagine, I will take 10 parts for training and one part for validation. One part for validation. Okay. Now this tells me that I am not touching the testing data set. I am only limited to training data set. So I have divided it into 11 parts. Out of 11, 10 for training, 1 for validation. Then what I do, I take this validation and shift it somewhere here, so that I was training on I was first training on these 10 parts. Now I'm training on some other 10 parts, and I'm testing on this first first part. Okay, then what happens, I might test on this and train on remaining 10 parts. Then I shift my testing on this part and train on remaining. Then I shift my testing on this part and train on remaining. So this way what happens, how many parts you have over here? 11 parts. Okay, so if you keep on testing on each part, how many times your data will be trained on this and tested on this training sample? It will be trained and tested 11 times, because with every part, first you are training on remaining 10 parts and then testing on this part. Then you are training on other 10 parts and testing on this part, right? So it goes on, so testing goes on one part and training on other 10 parts, and I keep on shifting it. In this example that I have taken, I have created 11 parts, so it will be called 11-fold cross validation. Okay, had I taken 10 parts, that would be called 10-fold cross validation. Now in this example, what I have done, I have fixed these samples. So if some sample belongs to this part, if some sample belongs to this part, it will always belong to this part. It doesn't happen like that. What happens is, suppose I don't divide my data set into parts. Okay, I don't divide. I just let me do it again. I just have this data set. Okay, I randomly choose and I say that I will divide my data set into, I want to do a 10-fold cross validation. So 10-fold cross validation means my data set should be divided into 10 parts. So what I'll do, I will choose, so suppose I have 1000 samples and I'm willing to do 10-fold cross validation. So what I'll do, I will choose 100 samples randomly. Okay, so I will choose 100 samples randomly and keep it separate. From the remaining 900, I will train. Okay, I will train. Once this training is over, I will test on this separated 100 samples. Okay, fine. That happens once. Now, in the next fold, that was called one fold. In the next fold, what I'll do, I will again choose 100 samples randomly. Okay, so you can say that it is quite possible that 100 samples that were selected in the first fold may also get selected in the second fold. Obviously they may, but that is not certain. We leave it to the probability, leave it to the uncertainty. But we choose 100 random samples again. Then third fold, again we choose 100 samples and we bring it as validation set. In third fold, again we choose 100 samples and bring them, and we do it 10 times. So now we do not know on what sample the model has been trained or not trained, on what sample the model has been tested or not tested. It's kind of a क्रॉस वैलिडेशन, कभी उस पर ट्रेन किया और फिर किसी दूसरे पर टेस्ट कर लिया, अब किसी और पर ट्रेन किया और बचे हुए पर टेस्ट कर लिया. सो इस तरह करके we do a cross folding, and so 10 times the data set has been, the model has been trained on this data set, and among that data set tested on some of the samples. That is called cross validation. Now what is stratified? Stratified means that if I choose samples and there are multiple classes, so if I choose samples, suppose this is my data set, I have chosen a wrong color. So if this is my data set and there are suppose 10 classes, let's say handwritten digit recognition problem. So how many classes you have? You have 10 classes because there are 10 digits. So when you do a stratified cross validation, so the 100% samples that the 100 samples, the 10% samples that you collect for validation, it should not happen that all these samples are belonging to few classes only. So like it has got 0, it has got 1, it has got 7, and none of the other classes. Okay, this is not a balanced testing or balanced training. So when I'm choosing the validation set, my validation set should be such that it represents all the classes fairly uniformly. So out of 100, I'm not expecting it to have 10 samples each. Okay, but at least say 9 sample for 0, then 8 sample for 1, then 11 sample for 2, then let's say 12 samples for 3, then 8 samples for 4, and so on, something like that. At least that should be there. Okay, so 10 sample for someone and something like that, dot dot dot. So it's fair representation of all samples in the validation set. So when you do a stratified key folding, what it does is it puts all the samples, all the classes uniformly in the validation set. So that is what I think it should be written in. Cross validation is often not used for evaluating deep learning model because of greater computational expense. For example, key fold cross validation is often used with 5 or 10 fold. As such, 5 or 10 models must be constructed and evaluated, which greatly adding to the evaluation time of the model. And you see, every time we do this, we discard model also. Okay, so when we do this cross validation, we discard every validation model also. So in this example below, we use the stratified keyfold class from the scikit-learn Python machine learning library to split up the training dataset into 10 folds. The folds are stratified, meaning that the algorithm attempts to balance the number of instances of each class in each fold. Okay. The example creates and evaluates 10 models using 10 splits of the data and collects all the scores. So this is how it happens. So in every cross folding, we create a new model, and then after the cross folding is done, we discard that. It means that we are not actually training on same sample again and again and again. I hope the question is clear now. Okay. Tessin asks that what is the line number 32 has got the verbose equal to and why it is used. Okay, if I tell you what is verbose, is my voice not clear? I think there should not be any issue with the voice because Had it like been, somebody would have complained. Sir, my voice is not clear.
No, sir, it's clear. Thanks for the explanation.
Fine. So I was telling the verbose. See, when I put verbose equal to 1 or 0, that means it controls how much explanation would be given at the time of fitting. Okay. So in this example, in the line number 32, I don't know where is line number 32, but when I'm fitting, I specify the verbose. So let's say in this example, I put it like this. Verbose equal to 0. Purpose equal to 0. So when I put purpose equal to 0, you see all these details, you will not find these details because I'm suppressing the uh, amount of conversation this training is doing with you. So now you observe epoch 1, 52 batches, epoch 2, 52 batches, epoch 3, all this will be suppressed. Let me run this code again. See, everything happened, but nothing was shown to you. Okay, no explanation was given to you. So that is the job of verbose. If verbose equal to 1, and which is by default, if I put verbose equal to 1, then it will explain everything to me. Otherwise, I can skip this. So these two scenarios, either I don't put what is verbose, or I put verbose equal to 1. In both scenarios, it will explain all the epochs. You see, epoch 1, epoch 2, all of these are properly explained and accuracies are provided to me for my understanding. That is the job of verbose. So over here, I have put verbose equal to 0. So if I run it, okay, this is again different. Can we interchange activation function used in different layers? Oh, of course you can. There is no issue with that. So you see, there are how many folds we are doing over here? I think doing a 5-fold cross validation. Yeah. So I have written 10 defined 10 fold, but just to demonstrate it in a smaller amount of time, I have done 5-fold cross validation over here. So you see in every fold, it is displaying you the amount of accuracy it is getting. Okay. So finally the 5th fold, average accuracy is 70.36 with standard deviation of 3.5%. Okay. So this is how we do the cross validation, and very quickly I will show you one more example in which I think so this I will run it very quickly, and you have the code with you, so you can also see what is happening in the actual code by running. And I think by now you all know how to run this. We have in scikit-learn, we have Keras classifier and Keras regressor functions in Keras, and using scikit-learn and Keras, it's a very great combination for doing machine learning and deep learning. So over here we have, see, from scikit-learn we import the stratified k-fold, and then we perform the cross validation score. So in this example, we use the stratified k-fold to perform 10-fold stratified cross validation. Now this is a resampling technique that can provide a robust estimate of the performance of a machine learning model when used on unseen data. We also use the scikit function cross val score to evaluate our model using the cross validation scheme, and then we print the result. So in this case, I think if I run it will show me some error because first the path is not correct, and then I think that it is loaded. So let me just use the third copy path, and I put this path into here, and I run it again. See, if verbose is still 0, so nothing is being displayed to you. Right, so these are the validation scores. Okay, so these are the results, and mean of the result means these are 62%, 70%, 64%, 59%. These are the 10-fold cross validation score, and finally you get a score of average 63% accuracy score. Now, grid search deep learning model parameter, this is a kind of program that is created to check different hyperparameters. Okay, what are the hyperparameters? You see, hyperparameter for any machine learning model is the parameter that you can play with. A lot of times people ask that, oh, okay, one question was right here, can we change the functions? Like this question, can we interchange activation function used in different layers? Yes, so that is what are called hyperparameter. Hyperparameters are things like which optimizer you want to use, what is the initialization criteria, what are the number of epochs with which the model will give better performance, what is the batch size with which model will give performance. Let me run this sample immediately, and I think, okay, where is there? Right. So while it is running, these are the parameters. So this grid search will do a hyperparameter search on how many epochs are good enough, what is the batch size with which my model will perform better, which optimizer is going to give a better result. So these are the parameters with which you can check and finally get an output. So this program will give you a complete output of what all parameters you can utilize and which set of parameters, because it is doing a combination, different permutation combination of parameters, and it will try to find out which combination of hyperparameter gives you the best result, and it will summarize the best result. It is going to take time, so you can ask question if you have any. Okay, is it needed to mount Google Drive every time after the session expire to open notebook? Yeah, definitely, because you see, I have 3 Colab notebooks, 3 or 4, and with every Colab notebook, the idea is that the Colab notebook must have mounted drive with them. Okay, if you have mounted it once, that is fine. Otherwise, if it is not mounted, then it will ask you to mount it. So I think in this one it was already mounted, but if it is mounted, then it will not. You can just check it if it's mounted or not. You want to unmount, you can unmount it over here, right? And if it is not mounted, it will ask you to mount it. That depends whether it is mounted for the session or not. Depends on the session.
Okay. If anyone have any further questions?
I think there is a question, how can we access multiple nested folder with multiple different file name in Colab? You see, for every file name that you want to access, you will have to specify the path. So you just go over here, and whatever file name you want to specify, just copy its path and specify the full path for that. Okay, so over here, like I have specified this path. Similarly, if you have another file for that also, you can, let's say I'm just giving a random example. So over here you have 2 files which you want to access. Okay, so first one is dataset 1 and second one is dataset 2, and first one has this path, second one suppose has this path, copy path. So you just specify that file's path, that's it. Okay, so this one refers to class 3, this one refers to class 2, and so on. So whatever file you want to access, you have to specify the path for that file, right? Any other question?
Okay. So my request to all the faculty members, those who are attending this workshop FDP, just kindly ask the questions accordingly so that we can discuss. Apart from that, I would like to mention that Dr. Munend will conduct one more hands-on with other models on the third day on the second slot, 11:30 onwards. So I'm just request is to those who are not aware, work on this Google Colab and this toolbox. If you have a query apart from that session on the third day, if again many things are possible, if you required from your side that you need many help, other help also, then I would like to conduct some more session hands-on. So my request is you must ask the question if you have a doubt. Otherwise, we assume that you are able to recognize the things and you are doing well. And accordingly, whatever the schedule we have given, we will move ahead then. Okay. So my request is to ask question right now through email or just send us some today feedback, not the Avidal portal you are giving, so that accordingly if needed, so more extra hands-on also I will conduct if needed. If not needed, okay, fine, that will be okay with us. So anyone have still question, please?
I think Sapna Sharma is trying to say something. We are not able to hear you, Sapna. You can write your question here. The thing is, as sir said, I have also, since I have shared these files with you, shared this folder plenty with you, you can make a copy, download these files and run it. And if
Sapna,
you
if you want, you can unmute yourself and ask if you have any query.
Yeah.
Yes. Sapna, you have any question? Yes. But we are not getting your voice. Sapna.
You can write over here, Sapna, if you want.
Okay, we are not getting your voice. You may write here.
Okay. Has anybody obtained the output of this code? Are you all running with me, or are you seeing what is the output of this code?
All are unmuted from our side. So those who have want discussion can unmute themselves and discuss and ask.
Sapna is actually unmuted, but she is not able. We are not able to hear you, Sapna. So you can write your question.
Yes, she has written something. Yes.
A long question. Session due to internet connectivity. Please take that into consideration. I would appreciate the recording of it immediately so that I could go through it, and when the next hands-on session is conducted, I will.
Sure, sure. We are recording that session and we are creating YouTube channel, and maybe today evening, maybe after 1 or 2 hours, it will be shared with you. Wait, it will be shared. It is right now recording is going on. So one session will be finished. Very soon it will be shared.
Are there 106 folders with 3 multiple folder? What does it mean? I think I have shared only one folder, so.
Sir, about the Adam optimizer. So can you explain a bit on that? Like internally,
Actually, today's
what
session,
kind of...
although I have not discussed about Adam optimizer or any kind of optimizer as such, I will discuss that in the class when I discuss, or probably somebody when they will start explaining to you what are optimizer in neural network, then they will explain it in a better detailed manner. The idea is when we do gradient descent, we take a learning rate. Okay. So in stochastic gradient descent, the normal SGD, the learning rate is constant. However, in Adam, we have learning rate variable, and that varies per neuron. So every neuron will have their own learning rate, and that is the main fundamental difference between stochastic gradient descent and Adam optimizer.
It will be discussed in one session in detail.
Yeah.
Okay, so in one session it will be discussed in detail how this stochastic to Adam adaptive momentum, and that detail it will be discussed. Okay. Okay. With this, no more questions are coming. Upen, are you here?
Yes, sir.
Okay, so we may close this
sir,
session
I'm
now.
here.
Yes.
So,
Yes.
KP,
thank
sir.
you, sir. for
Yes,
this
yes,
hands-on
yes.
session.
Yes, Muneendra.
Upendra, if you can
With
access
this
this
hands-on
folder, hello,
Upen,
Sorry,
sir, just listen.
could you access this folder that I have shared on the Google Drive?
sir, could you please repeat yourself?
Can you access these folders that I have shared on the Google Drive? I have shared the link of that also. So if you can access it, it's good. Otherwise, I have shared it for the participants to access them. If you can access this
Yes,
folder,
yes.
just let me know. You can access, right?
Yes, yes.
So you can see this, and if it is possible, probably share with the participants, and so that next time they come, they are well aware with the Colab file, and if they have any question, they can ask. Right?
So one question they are asking you, just you can see last one before we bind up. Muneendra, one question in the chat.
Is it possible local system? Yeah, that is a big issue. Actually, this happens. You see, we can do it. See, the idea is your local system. If your machine is running on the local system, like I told you, no, you when you connect, it says it gives you two options: hosted runtime or local runtime. So if it is hosted runtime, it means every computation is happening on Google backend. So at that point, you need to have your data at the Google server. Your Google Drive is actually hosted on Google server, so they are able to connect to them. But your local machine is not connected, and it is very tough to give it access to local machine. Even when you do this local runtime, that is also very tricky. You have to install so many libraries, and then it tries to connect to you, and most of the time your firewall will stop it. So it is not possible. As per, if you ask me, it is not possible to connect your Google Colab session with your local files. You will have to upload everything on the drive folder.
Okay. With this, we are going to close this session. So, Upendra, you may take forward now.
Thank you, sir, for your hands-on session. With this hands-on session, we are concluding today's day. So on this particular day, we had 3 different talks. Now we are about to end this particular session, and hopefully we will meet tomorrow in the morning.
So tomorrow talk will start at sharp 10 a.m. Today it was due to inauguration, it was delayed. But tomorrow onwards talks will start at sharp 10 a.m. So we'll meet and good night. We'll meet again tomorrow morning.
Okay, thank you, sir. Good night.
Okay.